I hope you can see my screen, I guess, right?
Yes, sir.
Yeah, fine. So today lab session is the third lab session. Say whatever we discussed till lab session 2 are the very basic instructions where everything is understood by the instruction itself. You are not developing any logic over there. Say your addition or subtraction or XOR operation or AND operation, all those things are well-defined function. Okay, like the function is already defined. Now we are going to try a different lab sessions where you are going to develop your own logic. See, whatever you did is a unique logic. Everybody has to follow the same logic. But what now onwards, everybody can develop their own logic to do a certain job. Like you will be given a problem, like you are supposed to write one program to do something that can be done by many ways. So I'll be showing the simplest one. If you are able to do other way, like more simpler than my program or more complicated than my program, you are welcome to practice it, you are welcome to do it. That's how you are going to develop your knowledge. Okay, so as far as today's lab session is concerned, we are going to start with our problem statement. Our problem is to find the largest or smallest number. Find the smallest or largest number in a group of numbers or array of numbers. You can say anything, group of numbers or array of numbers. So this is a problem you are given to you. You are supposed to write a program, assembly language program. Okay, this program will sort out the given data. Suppose you are given, let's say, 6 numbers: 05, 02, 07, 08, 09. Let's say this is a data set is given to you. Okay, so these numbers are stored in a memory location. Please listen, now onwards, we don't give the numbers directly. We always store the numbers in the memory location, and we will access those memory location and executing the program or running the program. So this is something like this. You will be given some numbers which are random in nature, will be stored in some memory location. Now you have to access these memory locations by using some commands, whatever the commands you are supposed to use. Okay, and you have to compare these numbers at the end of the program. At the end of the program, okay, at the end of the program, you are supposed to get lowest value or highest value in the A register or AX register. Listen carefully. You are given some data. That data is stored in some memory location. You are supposed to write a program by accessing those memory locations with all kind of instruction set what you are having. And you're supposed to find either smallest number among the given numbers or largest number among the given numbers. And that number should be in the AX register or AL register at the end of your program. Is this clear, all of you?
Yes, sir.
Yes, sir.
Yeah, now we'll try to say, please remember whenever you want to develop any assembly language programming for 8086, you need to first develop the logic. If you develop the logic, then it's easy to write the program. Remember, this is the first thing is you need to understand how what you're supposed to do exactly. Then you have to develop the logic. Now we are going to develop the logic. Okay, for developing logic, you can take a simple example. So if you want to develop a logic, so let's take 7 numbers. That means you are given seven numbers. Let's take 03, 05, 07, 04, 09, 1, 2, 3, 4, 5, 01, 08, 1, 2, 3, 4, 5, 6, 7. So now this is your data set. Okay, now you need to find out what is the largest number. So we'll write for largest number first. We write the program for largest number, then it's easy to convert largest number to smallest number. So our aim is to find out the largest number among the given data set. Now tell me, what is your answer?
8, sir.
Sorry?
9. 9.
9. So 9 is your answer. So at the end of our program, you are supposed to see AX value should be 09 or AL value should be 09. So this is your aim of your program. So now what we do is, if you want to do that way, so these are the steps I'm going to follow. Listen carefully. So this is the number 1, number 2, number 3, number 5, number 6, number 7. Listen carefully. So what I do is, first I will take number 1 into AX register. Listen carefully. And number 2 into BX register. Now once I moved AX and BX, like first number and second number, into respective register, what I'm going to do is, so how do you tell that greater than or equal? Which instruction I'm supposed to use?
Compare.
Compare. Very good. So what you do is, you use the compare instruction. Compare AX comma BX. What it does, it compare AX value and BX value. So after comparing, what you are supposed to do? Suppose if AX is greater than BX, or AX is less than BX. There are two options. Either AX can be greater than BX or AX less than BX. Okay. Now, if you want to find out the largest number, suppose if the first, this is the case 1. Listen carefully. This is the case 1 and this is case 2. Suppose if first case happens, what I'm supposed to do? If AX is greater than BX, what I'm supposed to do? Should I compare with the next number, or should I exchange the numbers?
Exchange the number.
No. If AX is greater than BX, since we want to find out the largest number,
then compare X with other number.
Another number. So if AX is greater than BX, you have to compare, because AX is greater than BX, that means BX is smaller. So we ignore the BX value. We compare AX value with the next number, right? But in our case, what is happening? AX is less than or greater than?
Less than.
Less than. So when it is less than, listen carefully. When AX is greater than BX is satisfied, what you are supposed to do is, you are supposed to compare with next element, compare with next data. But in our case, case 2 is satisfied. Listen carefully. In our case 2 is satisfied. That is, AX is less than BX. What I'm supposed to do now? I want to keep my final result in the AX register. What I'm supposed to do now?
So move BX to AX.
Why you want to move? You can use the exchange
We can exchange also.
exchange instruction, right? Exchange X comma BX. Now what happens? Whatever the BX value will move to the AX register. Is that clear, all of you? First step is clear. Tell me.
Yes, sir.
Yes, sir.
So now tell me, what is the AX value now?
03.
AX value. After the first comparison is over, your AX value is
05.
05. Listen carefully. Now what we are going to do, we are going to put a loop here. Okay, what this loop does is, it will again go back to the first loop. That means again your 07 will move to BX register. Listen carefully. In the next cycle, this is one cycle is over. In the next cycle, your 07 will move to the BX register. Again, AX and BX will be compared. Now what happens?
Exchange AX, BX.
Exchange X and BX.
Because AX is less than BX, again you are going to exchange the AX and BX value. That means your 05 becomes how much now?
07.
07. Now again it goes to the loop. Again it takes the next number to the BX register. Again compare with the AX value. Now which number should be compared now?
04.
07 and 04. Right? So
Yes,
now tell me, which condition is satisfying now?
Case
Case 1.
So case 1 is satisfied. When case 1 is satisfied, what you are supposed to do?
Compare with
BX.
another number.
So we no need to exchange this time. We are just go to the next loop. That means you are going to take next number into the BX register, again compare. So that means next time number will be how much?
09.
09. That means 07 and 09 will be compared. Now what happens?
Then exchange.
Exchange, because your AX is less than BX, so it will be exchange. So 09 will come here. Okay, now again loop will continue. Again it will load which number?
0, 1.
0, 1. Again it will compare. What happens now?
Then compare with another 0, 8.
Because 9 is greater than 1, it again take the another number, that means 0, 8 number. Again compare. What happens now?
Now exchange.
Now exchange 0, 9 and 0, 8.
Nah, so compare. But
So it compares. What happens to your result? Will it be same or different now?
AX09.
So x is 0, 9, right?
Yes, sir.
So how many iterations you have done? Tell me now. How many times you have compared with first value? How many times your AX register value is compared with other numbers? If you have a 7 numbers, how many times do I need to compare?
Sir, 6 times.
6 times. That's good. So you have to set your counter value to 6. You have to set your counter value to 6. So whenever you want to compare 7 numbers to find out the largest number or smallest number, you have to set your counter to 6 so that this loop will continue for 6 cycles. After 6 cycles, whatever the value stored in the AX register will be your answer. Is that fine, all of you?
Yes, sir.
So any clarification at this stage, let me know. Other students, is that fine, everyone? Logic is fine?
Yes, sir.
So
Yes.
you're using only 2 simple instruction. You're taking one number as a reference and comparing with all other numbers based on greater than or equal. You are actually exchanging depending on whether it is greater than or less than. Okay. Now we are going to write it in the program form. Listen carefully. This is the logic. Logic is very straight away. You have to iterate your comparison cycle for 6 times, 6 cycles, and you need 2 registers to do the job. If you want to find out the largest number in a given array, you need to use 2 register values and 1 counter value. So usually remember, counter value should be taken which register?
CX.
Always CX. Listen carefully. Your counting thing should always associate with the CX register. You should take CX as a counting number. How many times your loop supposed to be iterated? Okay. So you're going to use one compare instruction, one exchange instruction. What is the next instruction? What we have used?
counter.
Sorry?
Count.
Count, okay. Anything else?
Loop, sir.
Yeah, loop will be, how loop is connected? With which instruction loop is connected? Loop is connected to the exchange, right?
Yes, sir.
I mean, sorry, not exchange. Loop is compared with the connected with the compare. Based on the comparison, whether loop to be next loop will be executed. So you're supposed to see JG instruction, that is jump greater than, to the next loop. Okay. Now I'll show the program which I have already written. So we will just analyze the program and try to check out the result. Okay. So let me open the program. Hope you can see the program. All of you are able to see?
Yes, sir.
Okay. So if you look at here, listen carefully, line by line. So first I started with the origin, let's say 100 address. Now what I did is I cleared AX register and what is move SI, 4000H here?
Store the input.
Yeah, you are supposed to, you are going to store your input values at 4000 memory location. Whatever this one, move CL, 06. What it
Counter
does
value.
when you set, yeah, so you are going to give the counting number, how many loops it's supposed to be repeated. Now with this program, how many numbers I can compare? Tell me now.
7.
Only 7 numbers. So that's why. So you can manually either edit this number or you can also give some memory location address where you can define whichever the number you want. For the time being, I'm just keeping, I want to compare only 7 numbers. So that's why I kept my CL as 06. Okay. Now in the next instruction, what I did is, whatever the number in 4000 memory location will move to which register now?
AL.
AL. That means first number go to the AL register. So let me copy this program and let me explain you in this program. This will be easy for you to understand. Okay, is this fine now? Are you able to see the program?
Yes, sir.
Yeah, now we'll see.
Yes, sir.
Yeah, fine. Now we'll proceed and we'll try to see. So this is done. This is done. This is done at 4000 memory location. Let's say I stored these numbers. Let's take 03, 05, 06, 09, 04, 08, 1, 2, 3, 4, 5, 6. I think I'm done, right? 1, 2, 3, 4, 5, 6, 7. Okay, so these are the 7 numbers. This at 4000 memory location: 4001, 4002, 4003, 4004, 4005, 4006. Okay, now in the first, you have set my counter to 06. After this instruction, what is the AL value? After this instruction, what is the AL value?
03.
03.
03. Very good. So listen carefully. For the timing, ignore L1 number. This is a loop. We'll come back to this loop. Now, after moving 03 value to AL register, what I did is I incremented SI value. So what is the SI value now?
4001.
4001. When 4001, in the next instruction, move BL comma SI. That means 4001 memory location value will move to BL register. Now tell me, what is the BL value now?
05.
05.
05. So done. So now successfully you moved 2 numbers to AL register and BL register. In the next instruction, if you look at here, what is this? What is this instruction? CMP. You are comparing AL value with BL value. As I said, when you compare, you have 2 cases. First one is AL greater than BL and AL less than BL. Okay. So listen carefully. When AL greater than BL, so if you look at this instruction, jump greater than to L2. Listen carefully. This is very important. What it does is, whenever you compare 2 numbers, whenever AL is greater than BL, next instruction should jump to L2 line. Where is L2 line? Here. Are you able to see?
Yes, sir.
So it goes to L2 line. It will not perform this exchange instruction. So whenever your AL is greater than BL, do I need to exchange or not required?
Exchange.
When AL is greater than BL, generally I'm asking, not with respect to numbers.
Okay.
When AL is greater than BL, do I need to exchange or not required?
Not required, sir.
So now when not required, you have to skip these steps. That's why you are using a instruction called jump greater than L2. That means whenever AL is greater than BL, it's supposed to jump to L2 line. At L2 line, what is given? What is this? Loop L1.
Loop L1.
And that means after you find AL is greater than BL, it goes to loop L1. Where is L1? L1 is given here. You're getting the logic now? So after comparing AL and BL, if it's greater than, it goes to loop 1. What loop 1 is saying, you're doing now, tell me, you must have understand by this time, based on these two lines. What L1 is doing, it taking the next number, right?
Yes, sir.
Yes, sir.
Yeah, whenever loop 1 executed, it takes the next number from the memory location. You can see here, you're incrementing SI, that means previous it was 4001, it goes to 4002, and take this number to BL register. That means whenever loop is executed, your CX value will decrease by 1. Remember one thing, whenever loop is executed, or whenever jump greater than is executed, okay, your CX value will be decreased, or whenever exchange operation is taken place, so this value will be decreased by 1 number. Okay, now as for our numbers are concerned, okay, so this case is done. Suppose if AL is less than BL, what is supposed to do now? Do I need to jump or don't need to jump when AL is less than BL?
No need to jump.
So we have to exchange or not?
Exchange ALBL.
Yeah, so that's why when it is less than, it will not jump because it is not greater than. So it will execute the next instruction, that is exchange. Exchange AL comma BL. After that, it will go to L2 line. L2 line, you given loop L1. Again, it goes to your loop once again. That means again it takes the next number from the instruction. Okay. Now if we start with our numbers, now tell me what happened in the first instruction, first cycle. What happened in the first instruction? First cycle, 3 and 5 will be compared. Since 3 is less than 5, what I'm supposed to do now?
Exchange 3 and 5.
Oh, so exchange AL comma BL. That means your AL value will be 0, 5, right? So once this instruction is executed, it goes to the loop L1. Again, it goes to here. Now SA will be incremented. That means 4002 location. This 4002 memory location value will move to which register?
BL.
BL register. Now BL value is how much now?
06.
06. So in the next instruction, your 05 and 06 will be compared. Now where it goes program?
Again exchange.
Exchange.
Yeah, it goes to the exchange. Again, it will exchange because AL is less than BL, so it will exchange. So now AL value will become how much?
06.
06. After exchange instruction, which is, yeah, please.
Sir, when the program will know that AL is greater than BL, then only jump.
Yeah, exactly. That's the meaning of JGL2. Whenever AL is greater than BL, only jump to loop. Else,
So
it will execute the next instruction.
It may happen, no, sir, in the case of AL less than BL.
No. When AL less than BL, jump greater than will not execute. Like jump greater than will not execute to L2. See, if you look at here, this instruction itself, this compare AL comma BL itself says that whenever AL is greater than BL, this jump greater than instruction will jump to the desired location where we are defined. Otherwise, next instruction will be executed in the order, whatever order you are given. Is this fine? This JG instruction will be executed only whenever AL is greater than BL. Else, it will execute the next instruction, whatever the order you are written, without doing anything. Is that fine?
Yes, sir.
Okay. Now AL is 6. Now in the next cycle, what happens to your BL value? What value will be stored in the BL value when you go to the next loop?
09.
09. Now 06 and 09 will be compared. Now tell me again what happens?
Exchange will.
Again exchange. So AL becomes 9. Again it goes to the loop. Take the next number. What is the next number?
04.
04. Again it will compare. Now what happens in this case?
Then goes to loop 1.
Yeah, it directly goes to loop because AL is already greater than BL. So again it goes to the loop. So what is the next BL value?
08.
08. Again it will compare. Now what happens after the comparison? It will jump or it will go to the loop? It will exchange. It go to the loop because AL is greater than BL. So when it go to the loop, next number will be loaded into BL register. What is the next number?
07.
07. Again 0907 will be compared. So 09 is greater than 07. Now which instruction will execute? Exchange or loop?
Loop.
Loop. So loop will execute and that will be the end of your instruction because your counter must have got 0 by this time. The moment counter gets 0, your program will stop running. Is that fine, all of you? Hello?
Yes, sir.
Yeah. So we'll run in the emulator. It will be more easy to understand rather than looking at here. Okay. So some must be having some doubt. What happened when you both are equal? Did you get the doubt or not?
Yes, sir.
Yes, sir.
So okay, when you get both are equal, since this JGL2 is not satisfied to execute the next instruction, what happens when both are equal? Let's see. Let's say AL is 03 and BL also 03. Now what happens at this place when you compare? It is not less than BL, not greater than BL. So this instruction will execute only whenever A greater than B. Otherwise,
Loop will execute.
it just go to the exchange, right?
Yes, sir.
See, if A is greater than B only, it will jump to the loop. Otherwise, it will execute the next instruction. When both are equal, 03 and 03, which instruction will be executed now?
Exchange.
So exchange. So exchange will take place 03 and 03. So it doesn't make any difference, right?
Yes, sir.
So that's the one way. This is one way. I'll show you another way later part. For the time being, we'll first run the program and we'll see.
Sir,
Any
is
doubts?
this predefined jump instruction that it will happen only if A greater than B?
Yes. JG is defined such a way that I'll show you in the emulator. That's why I told you to check on the instruction set. Okay, anyway, I'll show you. So we'll write the new code. Go to new folder. So let me copy and paste this program as it is, since it's already executed one. So hope I done it. So what you do is, since you asked it, go to tutorials, documentation tutorials, go to instruction set. You can see here JG and JGE. Are you able to see? Here, where
Yes,
my
sir.
point. So click it. If you look at here, this is a short jump. A JG means a short jump if first operand is greater than the second operand. Is that fine?
Yes, sir, clear.
Right. Okay. Now we'll execute the program. So now program is ready. Now emulate it. So which memory location supposed to access based on my program? Which memory location I'm supposed to store my information?
4000.
4000. So update. Listen, I used 8-bit numbers because I used only ALBL. So you should not give 16-bit number. Okay. So tell me some numbers randomly. We'll store and we'll check our program is working or not.
01,
01. Okay.
03,
03.
09,
09.
07, 04,
0. Okay.
08.
08. 1 second. 1, 2, 3, 4, 5, 6, 7 numbers I'm supposed to give because I define my CL as 6. So tell me last number.
06.
06. Okay, done. So now you define your numbers which supposed to be sorted out and find the largest number. So we'll execute step by step. Hope you can see my simulation window, right?
Yes, sir.
Yeah. So we'll run step by step. Listen carefully and watch carefully. First step is clearing the X register. Done. Second step is you are supposed to move SI register with 4000 value. So 4000 is stored in SI. And you're going to set the counter to 06. So CL value will go to 06 now. So 06 is stored in CL register. In the next instruction, move AL comma SI. That means at 4000 memory location value will move to AL register. That means 01 should move to the AL register. And make sure when you are using AL registers, make sure your AH and BH value should not be any numbers. Is that clear? when you are using 8-bit numbers, make sure your AH and BH value should not have any numbers. If at all they are having some numbers, please make it 00 all. Then you start your program. That means you write one more line here, move BX comma 000H, so that your BX register also cleared. Okay. Now after this instruction, your 01 will move to AL register. Mode, all of you, can you see?
Yes, sir.
So now you are going to increment your SI, that means 4001 memory location. Let me give the memory here so that it will be easy to see. Okay. In the next instruction, your SI value is increased, that means 4001 memory location. We'll go to the 4000 memory location. So which value will go to the B register now? The next instruction?
03.
03.
03, yeah. So 03 is moved. Now in the next instruction, it will compare AL comma BL. Okay. So after comparing, now it has to decide whether to jump to loop L1 or should go to the exchange. Now tell me, which line it will go?
Exchange.
Exchange. So if you look at here, this yellow color line, it goes to the exchange line in the next instruction. You can see. Did it go or not?
Go.
Yeah. So now it is going to exchange the number. That means your 03 will be moved to the AX register in the next instruction. You can see now. Exchange numbers, AX
Yes,
and
sir.
BX. Okay.
Yes, sir.
Now IS number is in the AX register. This one cycle is over. Now movement executed, you are going to see CX value will be decreased. Now CX value is 06. Once exchange instruction is executed, it goes to the loop L1. Okay, observe carefully CX value. Did it decrease or not?
Yes,
Yes,
sir.
sir.
CX value. Yeah.
Yeah.
So that means the loop is connected to CX register. So whatever the number you give in the CX register, that define how many times your loop supposed to be executed. Okay. So once loop is executed, go to the loop L1, whatever the define you are defined L1. So what happens now? Again, it will increment the SI. That means 4002 memory location. And 4002 memory location value will move to BL register. Now tell me what is the BL value, expected BL value now?
09.
09. So 09 has come. Compared. So now tell me which instruction will be executed? Exchange or
Exchange.
jump? Exchange. So we'll exchange. So you can see exchange is done. Again loop, it went to loop. Now what happened to the CX value? Will it decrease or not?
Yeah. 04.
Yeah, it goes to 04. Again, you are going to increment your SI to the next memory location, that is 4003. Again, take that value to BX register. Again, compare AX comma BX, that means AL comma BL. Now, which instruction will execute this time?
Jump.
Jump, because this time AL is greater than BL. So now if you look at here, at this point of time, the next instruction will not go to exchange line, it will directly go to the loop L1. See this yellow color border in the next instruction. It will just skip the exchange instruction because AL is greater than BL. Did it jump or not?
Yes, sir.
Yeah, so that's how your jump instruction will execute, by skipping exchange instruction whenever AL is greater than BL. So this loop will continue till you get the CX value 0. Okay, so fine. Now which number is in BL? 08. So 9 is greater than 8. Again, it will jump. Next number is which number?
06.
06 will taken to BL register. 9 and 6 will be compared. And 9 is greater, so 9 will be in the register. So now at this instruction, listen carefully. Now what is the CX value?
01.
So in the next instruction, your CX becomes 0.
Yes, sir.
Then your program is over. Done?
Yes, sir.
So what is the X value now?
09.
09. Is that fine, all of you?
Yes, sir.
Yeah, fine.
Yes, sir.
Now what we do is, now as someone said, if numbers are equal, what happens? We'll try to edit one of the number and we'll try to see. So which number should I edit?
0808.
Okay, we'll make it somewhere 08. So 04, I'm making it 08, okay? Is that fine?
Yes, sir.
We'll reload the program. So now numbers are 01, 03, 09, 07, 08, 08, 06. So we'll quickly run till 08, okay? With all the single step instructions. We'll just running it fast. Till you receive 08. I think 08 will not come because 09 is here. Agree, all of you?
Yes, sir.
So it will not work in that way. So which way I'm supposed to edit numbers? Tell me.
03 two times.
03 two times. Yeah. So we'll replace 09 with 03. Yeah, I think this time it will work. Okay. Yeah, we'll reload it once again in the program. Now we'll start with first step. So 01 will move to AL register and 03 will be moved to BL register. 1 and 3 will be compared. Now which instruction will execute? Exchange or jump?
Exchange.
Exchange. So 3 will be moved to AL register. Exchange is done. In the next instruction, next 3 will be moved to BL register. Now both are same. If you look at here, your AL is same, BL is same. Now it is comparing in the next instruction. Listen carefully and check this flow, how it will go. So now it has to decide whether to jump or whether to execute.
Sir?
Yeah, please. Yeah, someone is asking doubt. Yes.
Can we write jump L1 directly rather than writing L2 then and loop 1 L1?
No. Jump L2 is a place where you return the loop. That's a kind of notation that we have used in microprocessor. Okay, you cannot write directly jump L1. That is possible in microcontroller.
Okay.
Can you? Okay, it depends upon the how instruction set is defined. Okay, in microcontroller you can directly write a jump L1 line. It will directly jump to L1 line without this extra loop and all. Okay. Hope I'm clear, I guess.
Not here.
Sorry.
Sir, why not here?
I did not get your question. Can you ask once again?
Sir, why can't we write here like that?
No, that's the depend upon the architecture, how your microprocessor architecture is defined, how the instruction set is defined. Okay, so you cannot see like CMP is a compare instruction. It's compare AL and BL, right? In the same way, you want to jump to the next instruction. That instruction should be located certain place. Okay, that place you are defining one more loop. You're supposed to execute one loop, so you're defining one location. Whenever the instruction reaches to that location, it will execute that particular loop. So you can see here, actually it is something like this. See, if you edit the program, let me tell you, so don't get confused. It is something like this. Is it fine now?
Yes, sir.
It is nothing but you're jumping to this instruction line where loop L1 is given. L1 is located somewhere here. It is just connecting a loop, closed loop, nothing else. We're actually connecting something like this from here to here and here to here. It's just a loop to execute our iterative cycles, nothing else.
Okay, sir.
Okay, so needn't to worry, it comes with the practice, needn't to worry. But meanwhile, if you can do that, like whatever you suggested, like jump directly to L1, okay, that is also possible because I did not go through full instruction set. Since it's a lab session, I just went through required instruction set. But if you can figure it out in microprocessor, but in microcontroller I did it, so that is possible, whatever you said it. But in microprocessor, I'm not sure, but you can figure it out with SAR or maybe with the instruction set. Okay.
Okay, sir.
Yeah, now we'll compare. Now it is comparing 3 and 3 in the next. Yeah, please. Yeah, now it is comparing 03 and 03. Now jump greater than will not execute. It will just execute AL comma BL. Listen and watch how this transition will take place. Did it jump or did it go to exchange instruction?
Exchange instruction.
So that means whenever you encounter two identical numbers, it is just exchange the two identical numbers. Doesn't make any sense. When you exchange two identical numbers, it will give the same result. result. Okay. So if you run full program, and I'm just running directly now, since you already understood when both are equal, so you got the answer. What is the largest number among these numbers?
08.
So you can see your value is 08 is here. Or if you want to test, you can test any other number also. So can we test other numbers? Can you give some other than a 0? Give something else. Let's say 12, 11, 14, 4, 23, 75. Is this fine? Some random numbers are given. Now tell me what is the largest in this?
75.
75. So the moment you run the program, you're supposed to see AL value with 75. I am running directly without step by step. Got the value X? Here.
Yes, sir.
So this is for finding the largest number in the given group. Listen carefully here. I want to tell you one more thing. As someone rightly pointed out, when both are equal, you have another instruction. If you look at here, JGE. Are you able to see JGE?
Yes, sir.
So it gives you jump greater or equal. Okay. So that means you can edit the same program. Listen carefully. I'm going to edit it now for your reference now. So JGE I'm writing. What it does now, tell me. When you compare both AL and BL, it's supposed to jump to the loop whether it is equal or whether it is greater than, both the cases. Is that okay? Will the program will work or will not work?
Work, sir.
Because when both are equal, you don't need to exchange it. So when you don't need exchange, you can directly jump to loop directly. So we'll just run it and just check it whether it will work or not. So just for a moment, let me define some numbers. Okay, 4000 memory location. Okay, so we'll make it 05, 03, 06, sorry, 06, 06, then 07, 09, and 08. Okay, so now I will run directly without anything. Okay, or else we'll just figure it out when both 006 comes, what happens. Okay, we'll directly execute till that part. Yeah, now we will try to see. Now we can see here, now both are 006, right? Here AL is 06, BL is 06. Now it compares. Now in the next instruction, jump greater than or equal. That means in the next instruction, it will just compare these numbers. It jumps whenever AL is greater than BL, whenever AL equals to BL also. Now in the next instruction, will it jump or will go to exchange? Now
Jump, sir.
it will jump. So we'll see now, it will jump. Did it jump or not? So I'll go back. You can see once again, it will jump to loop directly without executing the instruction exchange. Is that fine?
Yes, sir.
So, but if at all, if jump JGE is not there, it will execute the exchange instruction, but doesn't make any sense. Both the ways it is fine. Is that fine, all of you?
Yes, sir.
Right. So this is how you are supposed to find the largest number in a group of numbers in memory location. Now we'll try to see finding the smallest number. So you need to do only one thing. Only small change you are supposed to do. I am expecting you to give the answer. What change I'm supposed to do? I want to find the smallest number. Only one thing I need to change. Rest thing will be same. What change I'm supposed to do? I'm expecting some answer from your side. So, okay, let's find. So you are not able to answer. We'll try, we'll see. So these are the list of numbers which are stored in memory. Now we need to find out the smallest number out of this. Is that fine at least? Is that okay?
Yes, sir.
Am I audible or not?
Yes, sir.
Yeah.
Yes, sir.
So if you want to compare, if you want to find the smallest number also, what you do is out of given numbers, first take two numbers into AX and BX registers. So I'll take 04 and 03. Now I'll compare the numbers. Compare. Okay, when I compare, okay, listen carefully. I'm going to use the instruction called jump less than or equal. That means whenever AL is less than BL, or whenever L equals to BL, in this less than or equal to BL. Okay, whenever this happens, it's supposed to go to the loop and take the next number. You're getting my point?
Yes, sir.
Okay, whenever AL is BL, what I'm supposed to do? You're supposed to do the exchange. So whenever A is than BL or AL is less than BL, just go to the next number and take the next number and compare. If it is not, sir, suppose if AL is greater than BL, that means BL is the smallest number, A is the largest number. It will exchange the number. Apply this logic to these numbers. First 04 and 03 will be compared. Now tell me, AL is greater than BL or AL is less than BL?
L greater than BL.
So what should do now?
Exchange.
Exchange or jump?
Exchange.
Means you are supposed to exchange numbers. So AL becomes 03. Next number is how much?
01.
01. Now AL and BL will compare. Now what I'm supposed to do? Exchange or jump?
Exchange.
Exchange, because your AL is less than BL. So now AL becomes 01. Again, take the next number 05. Now
Jump.
directly jump. Okay, because AL already less than 05. Okay, anyway, I'll show the program and execute it once for you, and I'll stop for today's lab session. Let me go to the program. The program is same, nothing I change it here except one instruction. So let me make a new one. So hope you can see the program. Is everything is fine except this line. Everything is same. Agree, all of you?
Yes, sir.
Except jump less than, everything is fine. So you can use jump less than equal also. Both are fine. So you can use jump less than equal or JL also. Okay. So now we'll run this program to find the something is wrong. Or 2 times it came. Okay, we'll just, yeah, fine. So we'll emulate it. Done. We'll store the numbers in memory locations. Okay. 4000 memory location. Please tell me some numbers. We'll find the smallest number this time. Give about 10 numbers, not below.
17.
17, good.
13.
13,
21.
21,
27.
27,
11.
11,
31.
31,
19.
19. So 7 is done. 1, 2, 3, 4, 6, 7. Okay, done. Now we'll run the program. So we'll start with step by step, same as usual. So first, see, my counter is 6 already fixed since I taken 7 numbers. So please keep it in mind. So my CL goes to 6. In the next instruction, 7 will move to AL register. Sorry, 17. In the next instruction, SI will be incremented. 4001 memory location value will move to BL register. 17 and 3 will be compared in the next instruction. Now tell me what happens in the next one. It will jump or it will exchange?
Exchange.
Exchange, because 13 is less than, right? We want our number in AL register. So we need to exchange AL and BL. So if you look at in the next instruction, jump less than equal will not execute, it will go to the exchange line, like exchange instruction. So it goes to exchange. Did you see? It moved to the exchange instruction without jumping. Agree, all of you?
Yes, sir.
So it will exchange, that means 13 will go to AL register. So you can see now numbers are exchanged. Now again it goes to the loop, it takes the next number is 21. One will be compared. Now will it jump or exchange? 13 is less than 21. Will it jump or exchange?
Jump.
It will jump to loop directly. So it will go to the loop and takes the next number. Next number is 27. 27 move to BL register. Now again
Again,
Jump.
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 jump. Again jump. Go to the next number, that is 11. Now again compare. Now exchange or jump?
Exchange.
Exchange.
Exchange, because 11 is less than 13. So exchange will instruction takes place. Now in the next instruction, 31 will be taken to BL register. Again
Jump.
exchange or jump? Jump, because 11 is less than. Okay. Jump, again incremented. Next number is 19. 11, 19 compared. Jump or exchange?
Jump.
A jump. So now your counter is 0. Your program will stop. Done. You got the smallest number in the group, that is 11. Is that fine, everyone?
Yes,
Yes,
sir.
sir.
Okay, then. So this all for today's lab session is concerned. Okay. So in the lab session 3 report, what you're supposed to write is in lab session 3. Listen, this is only logic which I am following. You can find any logic which works and which will sort out the smallest and largest number. Don't rely on my logic. This is the simplest which I could figure it out to understand easily. Okay. So you have to write 2 parts. One is to find the smallest number. One is for largest number in a array of data. So you are supposed to show the screenshots of memory location values. Okay. And one jump instruction related screenshot, one exchange instruction screenshot. Okay. Same thing. You have to show the values which you stored in the memory location. One screenshot for jump instruction, one screenshot for AX instruction, and final result instruction. What is the final result of AX register value? So you require minimum 3 screenshot. I suggest you to go as many as screenshot, whichever you feel it is required to put it in the report. Is this fine? Lab session 3 report.
Yes, sir.
Yeah, now I'm giving a assignment. This is a graded assignment. And this will evaluate, this lab session reports also evaluated, but this is a assignment for the lab session. You're supposed to find the average of a given data points. So minimum of 10 numbers. So you're supposed to write a program which will access 10 members in a memory location. You are going to store 10 numbers in a memory location. Okay. These 10 numbers will be added one to one and sum up. That sum will be divided by the total number of elements, that means 10. And the final answer will be stored in the AX register. I need my answer in the AX register. Hope it is clear, all of you. Is this clear? You're going to find the average of 10 numbers which are stored in a memory location. You're supposed to use loop instruction. Or you're supposed to use some kind of iterative instruction. Please don't do that. First I'll take and add these two, then resultant will be added to the next. That's not that way. It automatically, like what we are doing for the smallest and largest number. Do we write for each element or we write for only one element? Comparison. How many times we compare, how many times we written the comparison statement, like compare 2 elements for the smallest and largest number?
So n minus 1.
Only one time, right?
Yes,
No,
sir.
instruction is written only one time, but that was executed 6 times. In the same way, you are going to find the average of 10 number. That means you are going to add the instruction called add instruction. This instruction has to be executed how many times now?
One time.
One time. It should be It should be written only one time, but should be executed 9 times, right?
9 10. Yes, sir.
Okay, so keep this in mind and develop your own logic and submit it as an assignment submission in the LMS. Okay, and one more request from my side, please submit your lab session reports at the earliest possible. I mean, like before next Tuesday, preferably in LMS, because if you send to my email, the problem is emails get accumulated. When I try to grade it, sometimes I may find it very difficult to figure out your these things and all. Okay, so my advice would be, please try to upload it in the LMS website. Okay, is this fine? Shall I close for today?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, so I request all of you, please practice on your own, explore on your own, then you learn as much as you want. If you follow someone else, then you may learn only the limited content. Okay, I request you to figure it out, different logics, different ways to do the same programming, so that you will familiar with different instructions, not only simple instruction. You may use multiple type of instructions in one program. Then you will get more confidence about the instruction set of microprocessor. Okay, then I think I'm done for today's lab session, and thank you all. Is everything is fine with the lab sessions? I mean, like the lab sessions are clear?
Yes, sir. Okay, sir.
Yeah, then fine. Thank you all then. See you next week.
Yes, sir.